to make it here. Oops. I better talk fast. I wanted to fast forward. I can't put everything out there, or I'll wind up rewriting this book. But I did want to discuss something interesting, like theorem 4.3.1. Do you recognize what it is, and do you recognize what theorem 4.3.2 really are? 4.3.2 is integration by parts, and 4.3.1 is integration by substitution. Right? I was going to prove 4.3.1. The proof's there. Well, I'll go through it next week. But I wanted to do some of the cute little problems here. Like
one is by substitution.
Yeah, 4.3.1 is the formula for substitution. 4.3.2 is integration by parts. And after you have the integration by parts formula, let's see if we can do this. Let's evaluate the Riemann-Stieltjes integral from -1 to 1 of x d absolute value x. That's problem A. This will show you the utility of the integration by parts formula. Right? So what's it say to do? As I keep writing, we're going to differentiate him and integrate him, right? Okay, so we have x, absolute x, evaluated -1 to 1, minus the Riemann-Stieltjes integral, or s, from -1 to 1, that's not much of an integral sign, is it? -1 to 1 of absolute x dx. This is the area under that graph, right? And what's this? When x is 1, this is 1. When x is -1, it's -1, but I'm taking that away. So it's 2 minus this area. You can see that that area is 1. So the total area is 1. So the Riemann-Stieltjes integral of x with respect to the measure absolute x is 1. Now here's a little harder one, but you get the principle P. The Riemann-Stieltjes integral from 0 to 3 of
Oh, are you just making this up? I thought you were doing ABC here.
Oh, I think you looked at it.
I'm on page 80.
It should be page 80.
Thank you.
Never mind.
X squared, I'm going to write the greatest integer function the way I usually write it, which is d floor function x. Okay? So what's that? Well, that last trick worked pretty good. Let's turn it around. If I integrate this baby and differentiate it, what do I get? I get 2x floor function x evaluated from 0 to 3, right? Minus the integral from 0 to 3, we're going to still just sense, integral from 0 to 3 of 2x, floor function of x, 2x dx. Right? Right? Okay. What's this going to be? No contribution at the bottom. At the top, greatest integer in 3 is 3. 3 times 3 is 9. I think this is 18. You get that? 2 times 3 times 3 is no contribution at the bottom. How about this one? Can we look at that? So here's 0, 1, 2, 3. What's this product going to look like? From 0 to 1, the greatest integer in x is 0, so it's nothing. And as soon as we get here, we hop. Now the greatest integer is 1, and if x is 1, I'm at 2, so I'm 2 units up, right? So I pick it up again at 2. Now, the greatest integer between 1 and 2 is 1, and I'm progressing at slope 1, right? So I think I would climb to 3 here, wouldn't I?
Is the first part of it in the book? This part? Evaluate.
I integrate him, differentiate him. Isn't he coming down? Oh, he isn't coming down yet. X squared, you're right. Okay. So 9 times 27. Thank you, sir. 27, not 18. All right. And then I got it right here, though. Maybe that's what I was thinking. 2x, and then this guy has been integrated. And now I'm looking at the graph of greatest integer x times 2x. So it's 0 to here, open here, close, hops to here, and then I get between 2 and 3, the greatest integer is 2, and at 2, 2x is 4 times 2 is 8 right here, right? So it hops way up to 8, and then it goes up. I did this wrong.
Okay, except that, why don't you break it into individual intervals from 0 to 1, 1 to 2, and 3?
Yeah. I was trying to draw the picture, but apparently I'm incompetent, so I'll just do this here. Let's try this. So, according to the name theory here, we go from 0 to 1. And this is 1, it's 2x dx. And then we go from 1 to 2, and it's, no, crap, this is 0. then it's 2x dx. I can't even get that right. And even still just 1, 2 to 3, x is now 2, greatest integer is 2, so it's 4x dx. And we stop at 3. So, no contribution there. That's a big 0. Here, this is x squared, 4 minus 1, that's 3. And this one is, 2x squared at 3 is 18 minus 8, that's 10. So I have 27 minus 13 is 14. I got 14. What'd you get? Sounds okay? All right. I'm just thinking out loud. What does the function